All right, let's talk Node.js. Specifically, the whole async versus sync thing. It can be a real headache, right? Well, to make it super clear, we're going to use an analogy that I promise everyone gets. A good old traffic jam. So what on earth does a traffic jam have to do with your code? You might think that's a weird question, but honestly, the answer is pretty much everything. You know that feeling, that absolute frustration when you're stuck, not moving? That is exactly what's happening inside your app when your code isn't running the right way. So, let's picture it. There's this super busy intersection. That intersection, that's your Node.js main thread. It's the one critical spot where everything has to pass through. Every request, every operation, you name it. The real question is, how are we going to manage all that traffic? Okay, first up, let's talk about the simplest way to handle this, which also happens to be the most problematic. We're going to call this the one-lane road, or synchronous mode. The rule here is super simple. One car at a time. That's it. One car goes, finishes its journey, then the next one can start. It seems orderly, kind of logical. But, and this is a big but, it has a huge, huge weakness. And look, as long as all the cars are zipping along, everything feels okay. But what happens when a giant, slow-moving truck rolls up? You know the one. In our world, that truck is a task that takes forever to finish. Think reading a massive file from your hard drive. And here's where it all goes wrong. Remember the rule? One at a time. So that slow truck, it blocks the entire intersection. Nobody can move. Cars are piling up, horns are blaring, and our whole system just grinds to a complete stop. It's a disaster. Now, this is what that actually looks like in your code. See that readFile sync? That is our slow truck. When Node.js sees this, it literally stops everything. It just sits there and waits for that whole big file.txt to be read before it even thinks about moving to the next line. It completely blocks the main thread. So yeah, you can see the chain reaction right here. A quick car gets through, then bam, the truck hits, and suddenly everyone else is just stuck, waiting. It is an absolute performance nightmare. So how do we fix this mess? Obviously, we need a smarter way to handle traffic. So let's check out a much, much better model. We're going to open up some more lanes with Asynchronous Mode. And here's where things get interesting. Look at this comparison. On one side, you have that single lane where one slow car ruins it for everybody. But on the other, we've got a multi-lane highway. Now, even if one car is slow, traffic just keeps flowing in the other lanes. It just works. So what about our big, slow truck? Well, the system is smart. It sees the truck coming and just diverts it. It moves it over to its own special lane so it doesn't hold anybody else up. And in the world of Node.js, that special lane has a name. It's called the thread pool. You can think of it as a crew of dedicated workers off to the side, ready to handle all the heavy, slow jobs. This keeps that main road, our main thread, totally free and clear for all the fast-moving traffic. Okay, so check out the async code. See how different this is? We tell Node to read file, but we also give it a little note that says, hey, when you're done with this, run this function. The key thing is the program doesn't wait around. It kicks off the file read and immediately moves on to the next thing, in this case, printing traffic continues. Absolutely nothing gets blocked. But wait, there's more. We can make our traffic system even smarter, even more sophisticated. This is the latest and greatest evolution, the Smart Sensor Upgrade, what we know as a sync/await. Now this is the high-tech solution. We're not just talking about more lanes anymore. We're talking about intelligent, AI-powered control. Imagine the system can lock onto one specific task, wait for it to be done, but, and this is the magic part, it does it without messing up the flow for anyone else. This really nails it. That await keyword, it's basically you telling the AI traffic light, look, I need to wait for this truck to pass right here in this function. But just pause this lane. Let everybody else keep moving. It's brilliant. And just look at how clean that code is. It almost looks like the simple synchronous code we started with, which makes it so much easier to read and understand. But under the hood, it's still completely non-blocking. You literally get the best of both worlds, easy to read code and super efficient performance. All right, that was a lot, I know. So let's pull over for a second and look at a final roadmap to make sure all these key differences are crystal clear. Think of this table as your ultimate cheat sheet. Let's break it down. Sync, that's our one-lane road. total blockage, CPU freeze, a real mess. Async with callbacks and promises, that's our multi-lane highway. Everything just flows. And finally, async/await, that's our super smart system with the AI sensor. It pauses just one lane, keeps everything else moving, and gives us beautiful, clean, non-blocking code. So, the next time you're starting a project, the question isn't just, will my code work? It's, how will my code perform? Are you going to build a little one-lane road that's just waiting for a traffic jam? Or are you going to build a smart, multi-lane superhighway that keeps everything flying along? Hopefully, this whole traffic analogy helps you steer clear of some major code jams down the road. Hey, if you found this useful, do me a favor and hit that subscribe button and give this a like. It really helps. Thanks for tuning in.